Imagine biting into a burger that wasn't raised on a farm but grown in a high-tech lab. It looks, tastes, and smells like the real thing and comes with a bold promise to revolutionize food sustainability. Lab-grown meat has captured imaginations as the answer to environmental challenges and ethical concerns, but does it truly deliver on these promises? Beneath its cutting-edge appeal lie deeper questions about its real-world impact. Let's explore whether lab-grown meat can live up to its claims, or if it's just a shiny mirage. Advocates of lab-grown meat highlight significant environmental benefits. They argue it reduces land use by eliminating the need for large-scale grazing and farmland, requires far less water than traditional livestock farming, and cuts down on greenhouse gas emissions by bypassing methane production from cattle. On the surface, these claims seem revolutionary, but the reality isn't so clear-cut. A closer look reveals that traditional livestock farming, especially pasture-based systems, doesn't always deserve its bad environmental reputation. For example, land used for pasture-based livestock often isn't suitable for growing crops. Animals grazing on this land contribute to biodiversity, nutrient cycling, and ecosystem health rather than consuming resources. Similarly, livestock water use is part of a natural cycle. Animals drink water and return it to the environment through natural processes, like urination and sweat. Unlike irrigation-intensive crops, grazing animals integrate with these natural systems, making their water footprint more balanced than critics suggest. While lab-grown meat might reduce water and land requirements, comparing it solely to intensive, industrial-scale farming ignores the nuances of sustainable, pasture-based practices. Lab-grown meat also relies heavily on energy, which raises an overlooked concern about its sustainability. Culturing meat in a lab requires highly controlled environments, nutrient-rich solutions, and constant temperature regulation, all of which demand substantial electricity. While proponents argue renewable energy can power this production, there's a catch. Renewable energy is already in high demand across sectors like transportation and residential use. Lab-grown meat competes for these resources, and until renewable energy becomes universally accessible, production will likely still depend on non-renewable sources. This reliance shifts the environmental burden from traditional farming to the energy grid, potentially creating new sustainability challenges. Greenhouse gas emissions are another key factor in this debate. Lab-grown meat promises to cut methane emissions associated with cattle, which are a potent but short-lived greenhouse gas. However, methane from livestock is part of the biogenic carbon cycle, breaking down over 10 to 12 years and converting back into CO2 absorbed by plants. In contrast, CO2 emissions from fossil fuels used to power lab-grown meat facilities persist in the atmosphere for centuries. This difference challenges the assumption that lab-grown meat is inherently better for the climate and highlights the importance of energy sourcing in evaluating its true environmental impact. An often ignored aspect of this debate is the role of crop farming in food production. Crops grown for human consumption and livestock feed require significant land, water, and chemical inputs, often through monocropping practices that deplete soil and harm ecosystems. Traditional livestock farming, particularly when it uses byproducts from crop production as feed, can help offset some of these impacts by reducing waste. Lab-grown meat avoids the need for animal feed, but doesn't address the broader environmental issues tied to crop farming. As a result, it may shift the problem rather than solving it entirely. Lab-grown meat also raises questions about unintended consequences. Scaling up production to meet global demand could strain renewable energy resources, diverting them from other essential uses. Additionally, a major shift away from traditional farming could disrupt rural economies and communities, creating social and economic challenges alongside environmental ones. For lab-grown meat to contribute meaningfully to sustainability, it must be part of a holistic approach that considers the ripple effects of its adoption. So, where does this leave us? The answer lies not in choosing one solution over another, but in integrating multiple approaches to build a more sustainable food system. Sustainable livestock farming practices, such as rotational grazing and holistic land management, can reduce the environmental impact of traditional farming. Advancements in crop farming, like indoor and vertical farming, can complement lab-grown meat by minimizing the need for monocropping and reducing water and pesticide use. Together, These methods can create a balanced system that leverages both natural and technological innovations. Lab-grown meat represents an exciting leap forward in food technology, but it's not the ultimate fix for our environmental challenges. Its success depends on addressing the realities of energy consumption, crop farming, and resource allocation. By combining the best of traditional practices with innovative solutions, we can work toward a future where food production supports both the planet and its people. The path forward requires more than a single solution. It demands a comprehensive strategy that integrates technology with sustainability. Only by seeing the full picture can we truly create a food system that meets the needs of today and tomorrow. Thank you for joining us on this exploration of food innovation and sustainability. If you found this discussion thought-provoking, don't forget to like, share, and subscribe to stay updated on future insights. Let's continue the conversation in the comments below. What do you think is the future of sustainable food? Together, we can shape a better tomorrow for our planet and the generations to come.